Good day. The topic we are going to consider today is derivation of trigonometric ratios. And let's see how these ratios are connected in terms of their functions. So the topic is derivation of trigonometric ratios. Okay, trigonometric ratios. Alright, so that's the topic we are going to consider today. Derivation of trigonometric ratio. Once again, we are going to make use of the right angled triangle that we used in the first place that we started this topic. The right angled, this angle is C, this angle is A, and this side is B with the right angled sign. Angle C is represented with theta, and so on and so forth. The side here is known as the hypotenuse with letter B. This side is known as the adjacent with letter A, and this side is known as the opposite with letter C. We need to quickly recall that sine theta is equal to opposite over hypotenuse. Opposite over hypotenuse. Then cos theta is equal to adjacent over hypotenuse, A all over B, and then tan theta is equal to opposite over adjacent, that is C all over A. Alright. So what we're going to look at quickly is how these things can be combined to generate certain ratios, okay, or relations, how we can use them to derive one or two things. So the ratio we are going to consider here as follows. One is the ratio of sine theta to cos theta, right? Right. So that's the ratio we're going to look at now. Sine theta all over cos theta. That's the ratio we're going to consider. And you know that sine theta is given as C over B, C all over B. Cos theta is given as, alright, cos theta is given as what? A all over B, A all over B. If we arrange this properly, we have sine theta over cos theta. Arrangement properly we give C all over B all over A all over B. Therefore, sine theta once again over cos theta, right? We now become C all over B times A, rather times B all over A, right? Okay? At this point, B will take care of itself, and we are left with C all over A. We are left with C all over A. And this means that sine theta over cos theta is equal to C all over A. If we check very well, you see that C all over A also means what? Tan theta. Therefore, finally, tan theta is equal to sine theta all over cos theta, all over cos theta. So, we have derived relation 1, okay? This is relation 1, okay? So we call it relation 1. The second relation that we're going to look at critically is the inverse of sine theta cos theta. Sine theta cos theta, the inverse. If we invert this, it becomes cos theta over what? The inverse, remember? We give a cos theta over sine theta, right? So cos theta over sine theta will give what? What will it give? It will give just, it will give cot theta. So that's the second relation here, alright? That's the second relation. Then the third relation we are going to consider quickly is a situation we have sine theta squared plus cos theta squared. cos theta squared all equal to 1. Alright? We can still prove this. What it means is for sine we have c all over b all squared, and for cosine we have a all over b all squared. Let's see if it is equal to 1. Let's see if it will give us 1. The essence of this is to check, after proving it, if it will give us 1. So here we have c squared b squared plus a squared b squared, right? Okay? So that is it. LCM at this point will give b squared, and then we have c squared plus what? A squared. That is it. Then we recall that b squared is equal to c squared plus what? A squared, right? So that is it. You can see here. Therefore from here, we substitute here now. We substitute b squared. So we have c squared plus a squared all over b squared is equal to b squared all over b squared. And that gives us 1. That gives 1. It has been proved. It has been proved that all this can give 1. So this relation holds. This relation holds. Is true. Yeah, that relation is true. Alright, so that's relation number 3. Relation number 4 is a situation we need to derive quickly now. We need to derive this without wasting time, okay? Relation number 4, we have sine theta squared plus cosine theta squared all equals to 1. Alright? From here we can get relation number 4, which is sine theta squared is equal to 1 minus cosine theta squared. Alright? So that's relation number 4. This is relation number 4. Relation number 5, dividing through, okay? If we divide through with sine theta squared. If we divide through with sine theta squared, we have sine theta squared over sine theta squared. That's the first one. Alright? Okay, here. Okay? Then plus cos theta squared all over sine theta squared over 1 over what? Sine theta squared. So what do we arrive at? The question is, what do we now arrive at? You can see that sine theta squared will cancel out. We have 1. Alright? Cosine theta squared over sine theta squared will give cot because it's inverse. Inverse, as we treated somewhere here, we give cot theta squared. We give cot theta squared, okay? Cot theta squared. And then 1 all over sine theta squared will give what? We give just a cosecant theta squared. We have cosecant theta squared. So that's it. We have generated what? Equation number 5, okay? So this relation now is relation number 5. Alright? It's just relation number 5. Okay, so without wasting time, we try to see what we can do to get that. This relation number 5. Okay? Now let's see how we can get, let's see how we can get relation number 6. This relation number 5. Quickly, relation number 6, we are going to divide with cosine theta squared, right? Because we have divided with what? Sine theta squared. We still retain this sine theta squared plus cosine theta squared all equals to 1. This time around, we are going to divide all through with cosine theta squared. Dividing through with cosine theta squared, dividing through with cosine theta squared. Let's see what will it give. So we have sine theta squared over cosine theta squared, okay, for the first one, we have this for the first one, okay? Then the next one is cosine theta squared all over cosine theta squared. What will happen? Then 1 all over cosine theta squared, okay? All right, we have succeeded in dividing through with cosine theta squared. You can see all this has been divided through with cosine theta squared. So let's see what the result will be. What the result will be at this point. Yes, sine theta squared over cosine theta squared. Sine theta squared over cosine theta squared will give tan theta squared. Alright? Cosine theta squared over cosine theta squared will give just 1. And at this point we have a second theta squared. Alright. Okay? At this point we have second theta squared. So this is the system relations. We have succeeded in deriving the relations between trigonometric ratios. Now let us see how these relations can be applied in solving 1 or 2 questions. That is what we're going to see. Alright, right away, we are going to clean this. Alright, we're going to clean this. Then the question, we're also going to clean this to have enough space. The question now is exercise 2 because we have solved exercise 1 in our first lesson. So exercise 2 is if cos x is equals to 5 all over 13, find I sin x. Alright? I tan x. So we start instantly without wasting time. Solution. Our solution is very simple. We first of all put down the one that has been given to us. Cos x is equals to 5 all over 13. Alright. Then the next thing we're going to do is to quickly look for the formula that will help us to solve this, that we can apply in solving this. And that is sin x squared plus cos x squared all equal to 1. Here we're going to make sin x squared is something sin x squared plus alright, is equal to now 1 minus cos x squared. We have succeeded in making sin x squared the subject, because that is actually the factor, or rather the quantity we are looking for. So the next step we're going to do is to substitute wisely and then simplify accordingly. Here 1 remains. For cos we have 5 over 13 all squared. Okay? So that is it. Then the next thing we are going to consider is 1, alright? 5 squared will give us 25, 13 will give us 169, alright? Remember, we are still working on this. Okay, this is the point we are, but that's not the final point. Okay, it is time for us to clean the other side for us to have enough space and then move on with this. Alright, the next thing is to find the LCM. Sin x squared is equal to 1 minus 25 all over 169. Alright, so the LCM here is 169. Remember, there is an unseen one here. There is an unseen one here. So we have to consider that 1 divided this will give us 169 minus 25, because 169 divide itself times 1 times 25 will give 25. When 161 divide itself, each will get 1, then multiply by 25 will give us all that. So finally we arrive at 144 all over 169. That is for sin x squared. Right? But there's something remaining here which we need to do immediately. This s squared has to be removed. Then we find the square root of both sides. We need to find the square roots of both sides. At this point in time, we need to find the square root of both sides, okay? We find the square root of both sides. And we do that right away. Square roots of both sides, right, is equals to root 144 all over 169, right? So this squared, we take care of this square root, and we are left with just sin x. Okay? The square root of 144 is 12. The square root of 169 is also 13, not 12. It's 13. Alright. So that is this is the answer to that question. Question I. So let's look at question number II. That is tan x. Tan x. What do we do? How do we get this? Tan x is very simple. We recall that we had this before now. Tan x, we can still use tan x is equal to what? Cot. Okay. We recall what we had before. Look at it. Look at the tan theta. Okay, from here, so we can have tan x squared. Let's have enough space. Okay, let's have enough space. We have a tan x squared is equal to secant x squared and then minus 1. For second, have a cos x squared, alright? Minus 1, okay? And that goes 1 over cos again, that's 5 all over 13 all squared minus 1. Okay? So that is it. You can see we're making progress. Then what we do? We just simplify once again. We have 1 all over 25 all over 169 minus 1. Remember? Okay, the next thing we're going to do, we do the simple arithmetical operation here, which is what? 169 all over 25 minus 1. At this point, we need to still find the LCM of this once again, and we arrive at 169 minus 25 all over 25. Okay? So that is how it's can be solved. So the next line of action here is for us to consider what is before us. Tan x squared is equal to 169 minus 25 over 25 will give 144 all over 25. Once again, we find the square root of both sides. And we have root tan x squared is equal to root square root 144 all over 25. And this will give tan x, because this will take care of this. Alright? Okay, then the next one is root 144 is 12, root 25 is just 5. Once again, we have found the solution to tan x, and that is it. Okay, the solution to tan x is this. Why the solution to tan x is this. So it's very clear. All right, I want to use this opportunity to thank you very much for your time, and I encourage you to remain at home, to stay at home during this lockdown period. God will help us. You must understand that we are doing this to keep you busy at home. You can as well subscribe to our YouTube channel at edekingsleylever.com. Like us on Facebook at thesameedekingsleylever.com. Follow us or visit us on Instagram, Pinterest, or Reddit, LinkedIn, WhatsApp, Twitter, and so on and so forth.